Good morning. Thank you for joining us this morning in this webinar. This morning we're going through Wiring Horner Micro OCS series. It's a relatively short video. It's about 15 minutes. And as usual, if you've any questions, feel free to enter them into your questions panel and we'll get to them at the end. Let's get started.
Welcome to today's tutorial. Let's get started. Today we'll discuss the different connections that you can make to the micro OCS. We'll discuss how to make the installation as smooth as possible, and we'll finish with a live Q&A session. Horner OCS controllers have a lot of connections, and that's true with the micro OCS as well, even though it is our budget product line. For the micro OCS, we selected connectors which may be different than those we've used before, for size and cost reasons. The micro OCS is much shallower in depth than our other controllers. The X1, X4, X7, and X10 use the same connectors regardless of the product size. Aside from those four models, our model X5 does things a bit differently, so we'll cover that as well. Now we'll talk about the power and grounds of the micro OCS. The micro OCS uses the same 3-pin connector that we use for all of our products. There are 3 signals made to the connector: DC power, DC common, and earth ground. There's some variance in the voltage range among the micro series. With the X1 to the X4 and the X7, those products require 24 volts plus or minus 20%. The X10 and the X5 can also be powered from 12 volts as well, but their lower end of the range is a bit different. The minus signal, or the voltage common, that's coming from the 24 volt power supply has many connections on the micro OCS itself. It has the same potential as the digital or analog I/O, the CAN common, the serial port common, and the USB common. The earth ground connection strictly has one connection on the circuit board. When you're installing the product, try get the ground as close to 0 ohms as possible. Anything up to 15 ohms is considered an acceptable earth ground. We use a 3-pin plug with 5.08mm spacing on the power connector. The screw type connector uses an M3 screwdriver. It's rated for 300 volts up to 10 amps, and you want to strip your wires back to 7mm. With stranded wiring, wire size is anywhere between 4 and 0.14 square millimeters. You can use up to 4 square millimeter wire with stranded and no ferrules. You're limited to 2.5 square millimeter if you decide to use a ferrule. If you use a double ferrule, you're limited to 1.5 square millimeters. I'll turn on my overhead camera. Let's show you the largest cable that we use here. We're talking about this 3-pin removable power connector. I have a 4 square millimeter stranded wire, and it is the largest size you can use with this connector. You can't use a ferrule with this size. If you want to use a ferrule, you can use a 2.5 square millimeter. 2.5 square millimeter stranded goes in without any difficulty, even with a ferrule. When you're trying to verify that a certain wire size will work with a ferrule, it's important that the wire goes in and out easily. It doesn't matter whether the die on your ferrule crimper is a flat-bladed crimper or a square one, although the flat-bladed ones tend to work better. So that was the power connector on the micro OCS. We would recommend that you use either a 2.5 or a 1.5 square millimeter wire for power. We would recommend a 2.5 square millimeter wire for earth ground, as it helps to get as close to 0 ohms as possible. One of the big benefits of using the 2.5 or 1.5 square millimeter wire for power is it provides an appropriate amount of copper for the current and the return signals. Voltage common is shared among all kinds of signals on the micro OCS. For example, I/O returns, communications returns, etc. That was the power recommendations for the micro OCS. Now let's talk about I/O connections. From a usability standpoint, the plugs are color coded. You've got 2 orange plugs for the digital inputs and the analog signals. You've got a black connector that is used for digital output signals. All plugs are removable, so there's no fixed terminals. You should use a small flat-bladed screwdriver to remove them. You can pry up one end to remove the connectors. When putting one in, you need to ensure that the plugs are fully seated by pressing solidly on both ends of the connector. These are 3.5mm plugs which use a slightly smaller screwdriver and M2 screw type. They're rated for 300 volts and 8 amps. The strip length is a bit smaller than the 508 plug for power. It's anywhere between 6 and 7. We've got a chart here that shows you some of the possible wire sizes when it comes to the AWT of bare copper with stranded wire, as well as the ferrules. Okay, now let's switch to the overhead camera and look at some of the wire sizes. Let's start with a 2.5 square millimeter wire. With no ferrules, you can very easily plug in a 2.5 square millimeter wire. It has a lot of ampacity and carries a lot of current. Many of the signals aren't near the requirement for the current with 2.5 square millimeters. If I flip this wire around with a ferrule on it and I attempt to connect, it doesn't fit. So 2.5 square millimeter is possible if stripped, but it isn't necessarily the best choice. Now let's try a 1.5 square millimeter wire, which goes in quite easily with no ferrule on it. With a ferrule on a 1.5 square millimeter wire, it doesn't fit. This particular ferrule uses a square crimping tool. Now, there are different dies or shapes. You can get different crimping tools for ferrules. There are ones that give you a rectangular crimp or a flat crimp, and there are ones that give you a square crimp. With the micro OCS, the flat crimp or the square crimp is superior. This is a 1.5 square millimeter ferrule with a flat crimp, and it's sliding in and out extremely easily. The crimper shape impacts how well the barrel goes in and out of the connector. So if you want, you can use 1.5 square millimeter with ferrules. When we go up to 1 square millimeter, then it fits regardless of the die that I'm using here. I'll switch to a square one, and you'll see that with a 1 square millimeter wire, it's not a problem. Hopefully that will give you an idea of which wires you can use. So here are some recommendations for using the I/O connectors. Use smaller wire gauges if you can. When you see the connectors, make sure you press down solidly, preferably until you hear a click, although you don't always get one. Once you've done your wiring, do some strain relief, so there's no strain on the connectors. With smaller connectors, it's important to properly strain relief the wiring, and it will yield a better result down the line. Keep in mind, you don't need to make every common connection. So depending on the model, you're going to see between 5 and 8 different connections on the 3 I/O connectors that are labeled common, but you don't need to connect them all. Through the power connector and the voltage common that's connected to the power connector, you have a return path. For things like analog signals, and maybe one input and output connection for common, it might be convenient to wire a few extra conductors to the common terminals. On the relay version of the micro OCS series, those commons for the relays are labeled C1, C2, C3, etc. And those are both mechanically and electrically isolated from the voltage common, so you don't need to connect 7 or 8 conductors for voltage common from your field terminal strip to the back of the micro OCS. With analog, we traditionally use much smaller wiring, but when we're talking about cabling, we always want to use shielded twisted pair wiring, and we want to make sure that we ground the shield drain to a good ground away from the OCS, so that noise is picked up away from the controller. If you're grounding it on the control panel side, you want to ground in a good panel earth ground and away from where you're landing. If you want to use ferrules, use a flat crimper. Now I'll switch to my overhead view and show you the difference. Here's what you would typically find for a crimper that gives you a square crimp. As you ratchet it, the square gets smaller and smaller. These are quite effective. When it comes to smaller type connectors or wires that are close to the size, these are definitely not preferred. The better choice is a flat crimp. And if I ratchet down a little bit there, these are more rectangular in their shape than they are square. That's what I'm talking about when I'm talking about a rectangular crimp versus a square crimp. On the analog side of things, we've been using smaller wire for years, and we recommend shielded twisted pair as the best choice there. For digital outputs, it really comes down to current draw. If you're using signals that are less than 1 amp, use a 0.5 to 1 square millimeter wire. If you're using signals that are greater than an amp, then use a 1.5 square millimeter wire. Those are my recommendations from a wire gauge standpoint with the micro OCS. Now let's talk about the X5. The X5 is quite different in terms of the I/O connections themselves. The X5 uses a 3.5mm pitch deeper spring clamp style connector. so the amount of insulation that you need to strip away from the end of your wires is 10mm, not 7. If you're going to use ferrules, they must have a barrel length of 10mm, not 7. For the X5, using a flat crimper is critical because it does not work with a square crimp at all. For digital I/O, I would recommend anywhere between 0.25 and 1 square millimeter. For analog I/O, the standard 0.14 to 0.25 square millimeter will do just fine. Now let's look at the connectors on the X5. I've got my X5 here. Now we're talking strictly about no ferrules at all. Let's try a 1.5 square millimeter wire, which is not going to fit well at all. Even if you aren't using ferrules, as I push down on that, it's not going in smoothly, so I would not recommend 1.5 square millimeter on the X5. What I have here is a 1 square millimeter wire, and I can plug it in here. One of the nice features of the Micro OCS X5 is these are pushing style connectors now. At first glance, that's going to work perfectly well. The problem is it goes in fine, but it doesn't come out fine, and that's not what you want. I was able to get it out, but it was a bit of a struggle. So 1 square millimeter wires I would say are marginal. If you use a flat crimp and you use a long ferrule like you should, you can use it. That's the upper limit of what you can use. If your application allows you to use 0.5 square millimeter wire, I would use it. I can push this in, and when I use the actuator, I can easily bring it out. It goes in and out very smoothly. A 0.5 square millimeter wire with a 10mm barrel on it is certainly what I would recommend for the X5. Now let's talk about CAN. So with CAN we've started using modular RJ45 connectors. This is actually a trend in the industry. We're not the only ones doing this. This CAN connector is pretty practical, it just takes a little getting used to. Like any other CAN network, your network will need to be terminated. However, with the Micro OCS, you can do the termination from the system menu, or you can choose to terminate the old-fashioned way on the field terminal strip. Patch cables work very well in connecting the CAN cable to the RJ45 modular jacks. European drive manufacturers have been using RJ45 and Cat5 cabling for CAN open servo drive applications for years with good success. Unshielded cabling for the modular jack connections to the patch cables is all you really need. You want to connect traditional CAN wiring to the Micro OCS outside of the enclosure. We sell an RJ45 to 5-pin cable assembly. We construct it using category style cable, and we connect the appropriate conductors, the CAN high and CAN low signal in the case of category type wiring. That's the orange-white pair. And then the common signal and category style wiring, that's the green-white signal. That's pin number 3 on the category side of things. With the Micro series, we give you 2 serial ports on a single connector. So you still have both an RS232 port and an RS45 half duplex port, both available to be used simultaneously. You can see the pin out there on the screen. Now to make wiring easier, we do have an accessory that is extremely popular, and that is an RJ45 2-terminal strip style adapter. Alright, let's switch back to the overhead camera to show you. Okay, so this is the adapter. You can see on one end it's got a modular jack or modular plug. On the other side, you've got 8 terminals. The pins are not 1 through 8 left to right. You have to pay attention to the sticker on the adapter to make sure that you get the right conductor connected to the right terminal strip. These are very handy products. If you're using it with, let's say, a serial port, it's a lot easier to wire that serial port using traditional communications wiring into that modular jack. And if we're talking about a Micro series product, let's say the X7, I'll bring in an X7 here, you can see that the way it's aligned, it's also very easy to make those traditional serial type cabling connections on the modular port. You may ask, what about termination resistors on RS45? You can use the system menu in the OCS to enable and disable termination, and you can do the same thing with biasing on the RS45 signals. Now back to shielding. If you're using a shielded comms cable, which is always a good idea, you need to connect the drain to an earth ground just like with analog signals. Don't leave it floating, it'll attract noise that way. For example, let's say you've got a variable frequency drive and an OCS communicating over Modbus RS45. A lot of the noise is being generated on the variable frequency drive side, so the best location to do the earth ground is on the shield side of the VFD. Now onto Ethernet and USB. With Ethernet, unshielded patch cables are fine most of the time. If you decide to use shielded cables, you need to make sure that the shield gets earth grounded. And again, it should be at the opposite end from the OCS. On the USB side of things, it's a matter of buying the right cable, and that is a mini B-type connector, and it's included in the Horner OCS cable kit. Okay, so that's Ethernet and USB. Thanks for attending today's tutorial. The Q&A session will begin shortly.
Okay, nice and short this morning. Just see if we have any questions in there now. Just the one so far. Do we have access to wiring diagrams? Yeah, you find the wiring diagrams for your controller on the data sheet. So those can be found on our website. We'll always have the most up-to-date data sheet on our website on the product page. So yeah, you can find it there if you need it. Not seeing anything else just now. I'll let you know what our next set of webinars is. So hopefully you can see my screen there now again. So next week we do have C-SCAN networking. And as usual, the registration links for all of these are here. But we have C-SCAN next week. Then following week, we're into PID control. Then into logic simulation IC. And then we have advanced map function blocks. We'd love it if you could join us for all those again. Yeah, I don't see any more questions coming in. Yeah, thank you for joining us this morning. We do hope to see you on those next webinars, and have a nice day.